Welcome to EDU World Space.
So if we want to find the surface area above this triangle, first let's go ahead and find what are our partial derivatives going to be. So we first need to solve for z. So we would just move everything to the other side, divide by 4, so we end up with z is equal to 5 plus x squared minus 2y all over 4. And now we can take our partials. So if we do the partial with respect to x, then it would be 2x over 4, which would be 1 half. So f x is 1 half x. And if we do the same thing, but with respect to y, so x is a constant, so it would just be negative 2 over 4. So f sub y is just negative 1 half. Alright, so we have our partials. Now let's go ahead and figure out what our region is. So let's draw this first. So let me put some tick marks down. So first we have the point 0, 0, 2, 0, and then 2, 4. So this here is our triangle. So this is all the area we're working with. Now, if we're trying to find like how this varies, first, this line we can write as y is equal to 2x, because we have the point 2, 4 and 0, 0. So that would just be a line of slope 2, y-intercept 0. And then the bottom bound for y will just be y is equal to 0. So we have where this ranges from 0 to 2x, and then x ranges from 0 to 2 in that region. So we already have our bounds as well, so we can use these to plug in. So let me erase this here. So this would go from 0 to 2, 0 to 2x, and then we just square those. So we square the partial with respect to x, which would give us 1/4 x squared. Y squared is going to just be 1/4. And then we still have that 1 floating around. And then we have dy dx. Okay, so we have the integral from 0 to 2, integral from 0 to 2x, and then if we go ahead and combine those, that should be 1/4 x squared plus 5/4 square root dy dx. Now, this first one doesn't actually depend on x at all, so we just go ahead and integrate that, slap a y on it, so it would be 0 to 2. Y times the square root of 1/4 squared plus 5/4 evaluated from 0 to 2x dx. So we're essentially just multiplying this by 2x. So it would be 2x times square root of 1/4 x squared plus 5/4 dx. Now to integrate this, we need to do a u substitution. So u is going to be 1/4 x squared plus 5/4. So then we get du is equal to, looks like just 1/2 x dx. Okay. So if we need 1/2 x dx, we can just go ahead and multiply this by 1/2 and then multiply on 2 on the outside, and then that becomes du. Actually, so let me just move that 2 out front as well, so it'd be 4. Now our new bounds are going to go from, so if I plug in 0, that'd give me 5/4. And then if I plug in 2, so 2 would be 4 times 1/4, which is 1, plus 5/4, so that would be 9/4. So our new upper bound is 5/4. And then this here is just going to become the square root of u, and then we have du here. And then let me just go ahead and rewrite this as a 1/2 power. So we can go ahead and use power rule and get 3/2, or u to the 3/2 divided by 3/2, and we evaluate from 5/4 to 9/4. Okay. So if we reciprocate that 2/3 and multiply that by the 4, it would be 8/3. And then if we were to do 9/4 raised to the 3/2 power, that should give us 27/8, and then minus, and I don't think 5/4 will work because 5 isn't a perfect square. So actually, let me write this off on the side to see what that would be. So it would be 5/4. Well, if this is to the 3/2 power, we can first write that as just 5/4 times the square root of 5/4. So that looks like it would just be 5/8 times root 5. So that would be 5 root 5/8. So these 8s all cancel out with each other, and now we're dividing everything by 3. So if I distribute the 3, we can actually write this as 9 minus 5 root 5/3. And this should be our surface area.